Well, thanks ever so much. So Brad and I are pleased to have this opportunity to participate today. Um, we are part of the firm's team, which also includes Diane Davies, who's the firm's manager, and developers, key firm's developers, Otmar Olchina and Asan Radov. Firms also has key contributors from the University of Maryland who provide kind of technical guidance and expertise. And Firms is part of NASA's broader near real-time system, which is called LANCE, and I'll go into that in a couple of minutes. And the LANCE team also includes Karen Michael, who is the LANCE manager, as well as Dawn Lowe, who is the LANCE consultant. Okay, so as far as an outline, what we want to share today is a really quick history and overview of firms and LANCE. We're then going to dive into the firms, primarily the FireMap interface. We'll spend a good chunk of time familiarizing you with firms US, Canada, and its functionalities. And I listed some other NASA tools and services at the bottom. I'm not sure we will have time to go into these today, but I will provide links after today's session. All right, so a very quick history on FIRMS. So again, FIRMS is NASA's Fire Information for Resource Management system, and the original kind of concept began in the early 2000s when there was a particularly significant wildfire year in Montana, which led the USDA Forest Service to approach the University of Maryland and researchers from NASA to look at the potential for using near real-time data and imagery to support wildfire management. And what is particularly relevant is that even the possibility of using near real-time data and imagery was due to the launch of NASA's Terra satellite in late 1999, followed by the Aqua satellite in 2001. Both of these satellites carry the MODIS instrument, and this instrument images the Earth every day, which meant for the first time that it was possible to have data and have it very quickly. These capabilities also occurred with kind of this rapidly evolving geopolitical environment, and this led to the MODIS Land Rapid Response System, and FIRMS was really built on the success of the system. FIRMS was originally developed at the University of Maryland. It was funded by two sources, the NASA Applied Sciences Program and the UN Food and Agricultural Organization. And then FIRMS was transitioned to NASA's broader near real-time system, LANCE, in 2012. So then what is NASA LANCE? So LANCE is the Land Atmosphere Near Real-Time Capability for Earth Observations. It provides near real-time data within 3 hours of observation in order to meet the needs of time-dependent applications. LANCE is a virtual system, which is kind of a key component of the system, and it leverages the science processing and archive elements that already existed within NASA. I think of LANCE as an umbrella system in which it includes kind of this specific set of requirements so that we can ensure consistency and efficiency and coordination, etc., which are obviously key for near real-time applications. It currently provides data and imagery from 10 instruments. Again, it started with just MODIS from Terra and Aqua, and now has 10 instruments. The imagery from LANCE is available through NASA Worldview, which is a free online visualization tool that provides access to over 1,000 global full resolution images. And LANCE really enables a range of near real-time applications such as air quality, dust storms, wildfires, which obviously we will focus on today, flooding, drought, you name it, multiple applications. Again, I mentioned this ecosystem that Lance leverages, and this is the range of archive elements that support the Lance system with the provision of data and imagery. I also mentioned that firms transitioned to Lance in 2012, and I think it's important to highlight that since that time, firms as well as Lance have continued to evolve really to support users through this kind of bottom-up, user-driven approach. Firms US Canada, which we'll focus on today, was launched in 2022. And then late last year, we actually launched an expanded user interface, really reflecting how the user base of firms has grown and really diversified. So what is firms? Well, firms distributes near real-time active fire data, imagery, and related products from multiple satellites, both polar orbiting and geostationary. These data, again, are available to the user within 3 hours of satellite observation, but frequently much more quickly. And they really provide critical information for wildfire management and associated impacts. While we're going to focus on the map interface today, firms is actually kind of this ensemble of capabilities. There is an opportunity to download data in multiple GIS formats. The users can sign up for fire alerts for an area of interest. The active fire archive from multiple satellites is available. There are multiple web services available. There's an extensive blog, tutorials, FAQs. It really does have a lot of different elements to it. So I mentioned that Firms US Canada was released in 2022. And so Firms actually has these two independent platforms, the original Firms, which is Firms Global, and this provides global near real-time and real-time active fire data and imagery, along with a number of interactive tools to visualize and analyze the data. And then Firms US Canada, which is a collaboration between NASA and the USDA Forest Service, provides the same near real-time and real-time products and utilities as Firms Global, plus ultra real-time data for much of the US and Canada. And Brad will go into this capability. There are also multiple contextual layers in Firms US Canada that really reflects the unique wildfire management situation in the US and Canada. I also, okay, let me see. What did I want to say about this? I'm not going to go through the whole table. It's a lot of fodder, but again, I mentioned this requirement of under 3 hours, but I wanted to highlight that many of the products are available in 20 to 30 minutes, and some of them even down to less than a minute. And finally, I have highlighted this ongoing partnership with US Forest Service dating back to the early 2000s. But Firms also has multiple partners that provide the active fire data and the imagery, the other geospatial products that are available in Firms. There are also multiple ground stations that provide data to Firms, as well as the ultra real-time data. And Brad will go into this more during the demo section. All right, with that, let me move on to I need 4 screens. I only have 3 screens, and clearly I need 4. So hopefully now you are looking at a web page. Can I just get a thumbs up? Or
Yeah, yeah, you're good to
okay,
go.
perfect.
Yep, Jenny,
All
we're good.
right, lovely. So this is the entry point for firms US Canada. We are going to spend the majority of the time here today in the fire map. I also wanted to mention that Brad will discuss a number of these at a later point in the presentation, and to highlight that up in this area, you can also access Firms Global, as well as the blog, tutorials, FAQs, etc. All right, when you move into the main firms map, the default mode is actually this basic mode, and this we consider kind of the entry point for new users. On the right here, under along this ribbon, if you click these 3 horizontal lines, which we often refer to as the hamburger, you can access the different modes that are available in firms. Some of these are thematically based, so the burned area and the smoke and aerosols. There's also an experimental mode, and this really contains beta or not quite ready for prime time products, but provides this kind of this platform for users to begin to interrogate those data. The other modes provide you with access to Firms Global, as well as the Fire Alert downloads that Brad will discuss. And then we're going to move into the advanced mode. And this is really where we will be today. And just to note that each of the modes will have a similar interface to the advanced mode. I consider this kind of a one-stop shop because it contains all of the products that are available in firms in one location, and it really builds on the other modes. So we're going to take a quick tour of the interface. In the top left, there's a zoom in, zoom out button. And then there's this very handy location tool, which you can use to navigate to your current location. You can also find a location by name or lat long, and you can also save locations here. Along the bottom is this ribbon that includes a measurement tool for distance and area in a couple of different units. There is a quick access to the location tool here. There is a timeline ribbon that we will go into in a minute. Quick access to the layers over here. These two I want to highlight. There's a really handy capture tool. So if you have built an image, a map that you would like to share with others, you can actually capture this in a JPEG, in a GeoTIFF, in PNG, and share that with colleagues. You can also share the URL of exactly what you're looking at and share that in an email with colleagues. And there's also this extensive help within firms, and then you can maximize the screen as well. And then next up is the main menu. This is kind of the main fodder for the interface. At the top, we have these kind of temporal elements. When you first load, you are looking at the default, which is the active fires within the last 24 hours. You can also look by today, the last 3 days, the last 7 days. I also wanted to highlight that there are these really handy tools up, these little eyes that are these tools that provide much more help on all of the different layers and modules within firms. There is also this handy calendar, which is a drop down and allows you to select the dates that you're interested in viewing. And you can also select up to 31 days back from the current date of interest. Next up is the fires and hotspots section, and each of these can be expanded and then reduced with this plus and minus sign here. For active fires, they're available from both polar orbiting as well as geostationary satellites, and the characteristics of geostationary and polar orbiting are different, and so they lend to different types of analyses. And so we will discuss these as we go through. The polar orbiting satellites are included from Landsat for most of the US, much of Canada, MODIS active fire from both Terra and Aqua, as well as the 3 VIIRS instruments, SMPP, NOAA 20, and then most recently we have included NOAA 21. For geostationary for the firms US, Canada, we're including active fire data from GOES 16 and GOES 18. GOES 16 sits at about 75 degrees west, and GOES 18 sits at about 135 degrees west, so there's extensive coverage of the US. And just to note that firms are making available 4 different active fire products from GOES 16 and 18, and this is due to the different algorithms that are being used by NOAA and King's College London to generate these active fire data. And the reasoning behind this is that the development of active fire products from geostationary is much less mature than active fire data from polar orbiting satellites. And we also, because of this, we also consider these a beta product, and we recommend that most users use the polar orbiting recommended active fire data. Let me see what else. You can also switch these all on and off with this click here, or you can turn each layer on and off. Like this, you can also change the opacity of the active fires. Moving on, let me just close some of this. All right, so next up, I wanted to move into this active alerts section. And in here we have, again, I mentioned that Firms US Canada really has been customized for US and Canada. And so we include, these are the USA active fires, and the icons are incident locations. These data are from NIFC, the National Interagency Fire Center, and they provide these data to firms. We also have equivalent data for Canada, and these are from, I think it's the Data Integration Project, DIP, in Canada. For both of these layers, they are capturing fires larger than 1,000 acres or 404 hectares. There are these red flag warning and weather watch layers for the US. There's a fire perimeter layer, and this is coming from the National Incident Feature Service. And we also have these forecasted fire danger layers for the US and Canada. And again, this is a really brief overview, but if you click on each of these eyes, it gives you much more information on each of the data sources. All right, I will come back to the orbit tracks and overpass times. Next up is the MODIS burned area module. I'm just going to highlight that this contains a monthly product, so it's not real time, and it's not near real time, but this product goes back all the way to the year 2000, and there is an approximately a 2 to 3 month lag between the generation of this product and the availability within firms. The smoke and aerosols I'm going to come back to in the demonstration as well. And then the overlay section, this really contains kind of handy layers that provide additional context to what you're visualizing, protected areas, the National Geographic Area Coordination Centers, or GACs, as well as these other layers. The harmonized Landsat Sentinel imagery, or HLS, and the dynamic imagery sections I'm going to come back to. And then finally, the static backgrounds. And these you can just click on and off to give kind of different visualizations to what you are looking at. All right, so that's kind of the tour of the interface. I know that was a lot of information, but obviously as you play around with it, you will come across most of these features. So now I wanted to move on to kind of a few specific demonstrations. First of all, I wanted to show the use of firms for looking at regional fire patterns, the use of the calendar feature up here, as well as the timelines down here, and then this time-based feature. All right, so we are going to look at regional fire patterns in September of 2022 in the Western US and Canada. Obviously, a big wildfire year. And for this example, I'm using the active fire data from NOAA 20 and the VIIRS instrument on board NOAA 20. These data have a spatial resolution of 375 meters, which means that an active detection is somewhere within those 375 meters. And I wanted to step through these kind of 5-day increments to highlight these fire patterns. So to do that, you select the date that you are interested in using the calendar dropdown, and then again you can look at up to 31 days preceding. And so I've set this to 5-day increments, and these are kind of these chunks of time. So now we're looking at the 5 days between the 26th and the 30th of August. I also have selected this time-based option. There is the simple detection, which just shows all of the active fire. The time-based, you can either look at within the last 24 hours or in increments of days up to 5 days. And so in this first period, what you can see are these older fires in the northeast of Alberta. So these were detected kind of 3 to 4 days out. So there are no kind of new detections, but we do see some new detections. You can see from this dark red in the central area of Idaho, as well as up through the north. And I would just keep an eye on this area, the southwest of Oregon, as well as the northeast of Oregon. If we now step through using these arrows down at the bottom, so now we're going to step through to the next set of 5 days. And so now you can see this significant expansion of, let me just go back and forth. So you see this expansion of active fires in the northeast of Oregon. This is actually the Double Creek fire, and the southwest of Oregon, as well as this expansion all the way through the central and northern area Idaho. But really, there are very limited detections up in the northeast of Alberta. And then if we move through one more time, again, you see these significant expansions. Again, the Double Creek Fire, as well as this area down in kind of central Western Oregon, as well as up through Idaho. And then finally, if we move through to this final 5-day period, we are getting less new detections, and that's evidenced by these yellow and orange detections, which are older. And so this example really highlighted the use of firms for looking at regional fire patterns, and this was over a period of almost 3 weeks, using this time-based feature, as well as the calendar and the date stamp period and the timeline at the bottom. All right, the second example that I wanted to show, let me turn off the JavaScript there. For this, I'm actually making use of both the VIIRS and MODIS active fire data. This is from a single day, the 9th of September 2020. And we're also going to dig into, I'm going to close a few of these, this dynamic imagery section, which is down here. Again, I am using the time-based feature here. And you can see there is a lot of wildfire activity throughout much of California, the central and northern parts of California, as well as Western Oregon. And I'm just going to highlight, I have 2 dogs, and occasionally they bark. So in full transparency, if you hear a bark, I apologize, but one of them just got up, which is usually not a good sign. All right, so within the dynamic imagery, I actually have the MODIS Aqua corrected reflectance imagery on with these 3 bands, 7, 2, 1. And these are, this is a very relevant composite selection, because these are called false color composites, and they have very different characteristics to what are called true color composites. And true color composites, you will see here, they are in brackets after each one, it says true color. And that true color are essentially what our eyes would see. So these are available daily for VIIRS and for MODIS. And they have a spatial resolution of 250 meters. The GOES data are also available in a true color composite, and they have a spatial resolution of 1 kilometer. These data are actually acquired every 10 minutes, and they're available in firms within approximately 40 minutes. And Brad will go into the geostationary later on. Now, the beauty of the false color composites is multifold. First of all, false color composites are really useful for looking at burn scars because of the characteristics of burn scars. They're also really useful for differentiating clouds from smoke. They can also see through clouds much more effectively than the true color composite. So if I now just pop on the MODIS Aqua True Color Composite, you can really see these massive plumes of smoke emanating from these wildfires out through the Pacific, and that can be contrasted with these areas, which are cloud. Okay, so you have clouds here, and then smoke up in here. And so again, if I pop back on the false color composite, you can see this great separation of the clouds here, the smoke here, but also you can see how you can get more of the land through this particular composite. So the false color composite and the true color composite can be used in different ways. Okay, the third example is smoke and aerosols. And what I wanted to quickly highlight here, and again, there is a separate smoke and aerosols mode, but the same layers are available in this one-stop shop advanced mode. And these layers are really useful for both identifying and tracking aerosols. So from smoke from wildfires, for example, but also, interestingly, dust from dust storms, such as huge dust storms in the Sahara. Currently, we have two products available here. There is an aerosol index product as well as a Pyro CB product, which is particularly helpful for these massive wildfire events where there's a huge amount of smoke pumped up into the high atmosphere, which in turn can have generate weather events as a result. The UMPS is available. It's the SMPP UMPS, but we will also have aerosol index products from both NOAA 20 and NOAA 21. Those are in progress, and those have a finer resolution. The spatial resolution of the UMPS aerosol index is actually 2 kilometers. So it is quite coarse, but again, it's particularly helpful for identification, but also the tracking of these aerosols. And in this image, we are looking at these significant swath of high aerosols from the Canadian fires from May of last year, and you may have experienced multiple days of poor air quality up in Minnesota. If I actually turn this off for a moment, and if I change to the, let me see, the false color composite, right here, you can see the smoke from the active fires up in Canada. And again, if you compare that to the true color composite, again, you see these significant smoke events compared to clouds over in this area. All right, and then finally, I wanted to spend a few minutes on some of the mechanics of satellites, because this really impacts time-sensitive applications such as wildfire and other applications. So a few points to note, and some of you may well know this, in which case it's a refresher. For others, it is perhaps new information. But again, I mentioned we have both polar orbiting and geostationary active fire data. The different polar orbiting satellites have different pixel sizes. So I mentioned that the VIIRS instrument has a pixel size of 375 meters. MODIS is coarser; it has a pixel size of 1 kilometer, and Landsat has a pixel size of 30 meters. The satellites also orbit the Earth in different frequencies. So let me show you how that works. So if we pop on within the orbit tracks and overpass times, this contains the orbit tracks for all of the polar orbiting satellites that we include in FIRMS. So I wanted to pop on the SMPP day overpass. And these are the times in UTC that the satellite overpasses a different location on the Earth for today, the 4th of April. I mentioned that the satellites overpass twice a day, once during the day and once during the night. And so these are the nighttime overpasses. And these times vary slightly each day. Okay, if I now pop on the Landsat data, this is the Landsat overpass for today. This is Landsat 9. And then again, tonight, again for Landsat 9. Now, while the VIIRS and MODIS are able to overpass twice a day, each Landsat instrument can only revisit the same spot on the Earth every 16 days. So between Landsat 8 and 9, that's about every 8 days that that a Landsat instrument overpasses the same location. Okay, we are getting there. In addition, each satellite has a different swath width. And I think that will be helpful to, once we look at this. I'm actually going to go back to March the 31st, because it takes a couple of days for us to get the Landsat imagery. If I pop on the Landsat imagery for the 31st of March, the Landsat data have what's called a swath width, so that's this distance, of 185 kilometers. So it takes more time, more passes of the Earth to complete coverage of the entire Earth. And that's why there is this revisit time of approximately 8 days. If I pop on the MODIS imagery, okay, now you can see this swath width, which obviously is covering a larger area of the Earth. The MODIS swath width is approximately 2,300 kilometers. And so you can see why it's able to image the entire Earth approximately twice a day. And then the VIIRS imagery has a swath width of approximately 3,000 kilometers. And so it covers even more area on each overpass. And so this is the main point, that the different sensors have different pixel sizes. They have different repeat frequencies and different swath widths. And these factors in turn impact whether or not an event such as a wildfire event is detected because of this combination of factors. And then finally, let me pop forward to, actually, let me show you one additional point while we're on the 31st of May. I mentioned the geostationary satellites, and these there are 2 available for coverage of the US. GOES 16 and GOES 18. These have a much coarser pixel size. It's approximately 2 kilometers right below the satellite. These geostationary satellites don't orbit the Earth, but they kind of rotate back and forth above the equator. And I mentioned that GOES 16 is situated at about 75 degrees west, and GOES 18 is over in this area. And again, they image the Earth every 10 minutes. And so this is very relevant for wildfire management because there are more opportunities to detect a wildfire. If I pop on the GOES imagery, you can also get an idea of the coverage of GOES. This is GOES 18 over the entire expanse of the US. And then if I move back to today, I'm going to highlight one last thing before I pass it over to Brad. I mentioned that the satellites overpass at different times, and so this then impacts when an image is acquired. And so, for example, if we look at NOAA 20 for today, you can see that due to the overpass time, much of the US has not been imaged by NOAA 20 as yet today. And if I then pop on the orbit tracks, that shows you when this particular satellite is going to image a particular area. And so you can use that for your area of interest to know when that satellite overpasses, but also understand why a wildfire may not be visible because the satellite has not as yet passed over for today. And then my final point is pixel distortion, which essentially, as let me just pop on one more. Let's see how we're doing on MODIS. Okay, this will work. So now we're looking at a MODIS Aqua image. We might actually have a better. Okay, so this is MODIS Terra, and it has a morning overpass. I mentioned that the pixel resolution is 1 kilometer. The pixel resolution for a VIA's pixel is 375 meters. But at the edge of the swath widths, here and here, there is distortion of the pixels. And so this then can impact kind of where in the pixel the location of the active fire is situated. So for the polar orbiting satellites, it's the east and the west edges that are mostly affected. For the geostationary satellites, because the kind of the central point is the equator, as these satellites look to the north and look to the south, there is much more distortion. And so, for example, in Canada, this really has to be considered when using geostationary active fire data because of the potential for distortion and mislocation of the active fire within a particular pixel. All right, hopefully everyone is still standing. And with that, Brad, I will pass it over to you.